physics teachers. As you now know, climate change is one of the most significant issues of our time, and its impacts are becoming inseparable from our day-to-day lives. It is critical that our students are made aware of this issue and that they understand this problem from different disciplinary perspectives. In this lecture, we show the connections of Earth's climate and physics and show how you can teach some topics in physics using a climate-related example. In this lecture, we present educational resources that bring climate studies into the mainstream undergraduate physics curriculum. These resources will allow you, a physics teacher, to teach topics in physics using a climate-related example and where you do not have to deviate from your prescribed syllabus. This will lead to increased climate awareness of your students. I would like to reiterate, using these educational resources, you as a physics teacher can continue to teach topics in physics as per your syllabus, but your students will learn more about climate change. Using these digital pedagogical resources in your physical classrooms, you can learn how to incorporate a multidisciplinary approach to teaching. How do you introduce relevant topics, in this case climate change, in your discipline teaching? How do you use technology in the classroom for effective learning of your students? And how do you enhance student learning and their experience in the classroom? You can integrate climate science in your physics teaching and use educational resources to teach topics such as black body radiation, the Stefan-Boltzmann's law, Planck's law, heat transport, convection, energy and mass conservation, the electromagnetic spectrum, Coriolis force, Hadley circulation, planetary energy balance, and many others. Let us take a look at a few lesson plan examples that you as a physics teacher can teach using a climate-related example. Some of these which we will show in this video lecture include how to teach about Planck's law and black body radiation, phase diagrams and phase equilibria, the Coriolis force and the Coriolis effect, heat transport specifically in the atmosphere, Hadley circulation and its effects on Earth's climate. Let us take a look at our first lesson plan titled Teaching Planck's Law and Black Body Radiation. As an undergraduate physics teacher, you can use the set of computer-based tools shown in this lesson plan to help you in teaching about topics such as Planck's law, the Stefan-Boltzmann's law, and black body radiation. This lesson plan will allow your students to visualize the emission spectra associated with particular temperatures, to understand how Planck's law can be used to plot black body curves of objects with different temperatures, and to learn the relationship between temperature and peak wavelengths in the electromagnetic spectrum. The activities in this lesson plan also introduce the topic of planetary temperatures of objects in the solar system and shows the greenhouse effect of the Earth's atmosphere. Thus, the use of this lesson plan will allow you to integrate the teaching of a climate science topic with a core topic in physics. So, as a physics teacher, if you are teaching topics such as Planck's law, Wien's law, black body radiation, the Stefan-Boltzmann's law, what might be the relationship between temperature and peak wavelength in the electromagnetic spectrum, planetary temperatures as a function of solar energy received, you might want to use a lesson plan such as this to integrate topics in physics with a climate science topic. This lesson plan might take anywhere between 120 to 150 minutes in your classroom. This lesson plan includes a visualization and an associated activity to explain how Planck's law can be used to plot black body curves of objects with different temperatures, the relationship between temperatures and peak wavelengths in the electromagnetic spectrum, and the greenhouse effect of the Earth's atmosphere. It also includes a classroom and lab activity in order to understand the energy balance of planet Earth, the Stefan-Boltzmann's law, and the solar energy flux received by planet Earth to calculate its surface temperature. This resource can be used to demonstrate the greenhouse effect of the atmosphere. Here is a step-by-step guide to using this lesson plan in your classroom. We have suggested these steps as a possible plan of action. You may customize the lesson plan according to your preferences and requirements. First step, introduce the topic, discuss the concept of electromagnetic radiation, and proceed with your existing lesson plan to explain what is Planck's law. Next, discuss how the Planck equation can be used to plot blackbody curves of objects with different temperatures and what might be the relationship between temperature and peak wavelengths in the electromagnetic spectrum. You can explore this topic in an interactive and engaging manner through a visualization tool and an associated activity. This tool, developed by PHET, is titled Blackbody Spectrum and is available at the link shown here. You can also download an activity that has been developed by the National Science Teaching Association, which is titled Exploring Planck's Law, that was designed to be used with the PHET Blackbody Radiation tool. With the help of this activity, you can explain to your students how Planck's law can be used to plot blackbody curves of objects with different temperatures and the relationship between temperature and peak wavelength in the electromagnetic spectrum. The activity contains several questions that you can give your students to answer in their classroom or lab activity. You can then continue this lesson plan. You can introduce the Stefan Boltzmann's law as a means of calculating the total flux of energy emitted by a black body. Stress to your students how this law can be used to calculate the surface temperature of different black bodies. You can discuss the topic of energy balance and planetary temperatures in the solar system and show that the surface temperature of planet Earth can be calculated on the basis of the solar energy flux that it receives. At this point, you can introduce the greenhouse effect of the Earth's atmosphere and show how the surface temperature of Earth increases from a bare black body Earth to a black body Earth with a one-layer atmosphere. This activity, titled the Layer Model, has been designed by David Archer at the University of Chicago, and it contains an activity in this particular exercise. So, you can continue to teach topics in your syllabus, which include things such as black body radiation, but you can tie it in with understanding how black body temperature can be calculated for planet Earth with no atmosphere, with a one-layer atmosphere, with a two-layer atmosphere, and therefore show the greenhouse effect of the Earth's atmosphere. This way, your students will also understand aspects of climate science, specifically what is the role of the atmosphere in calculating the surface temperature of planet Earth. You can use the tools and concepts learned in this lesson plan to discuss and determine answers to the following questions. How can Planck's law be used to plot black body curves of objects at different temperatures? How can the Stefan Boltzmann's law be used to calculate the surface temperature of black bodies? Why does the surface temperature of Earth increase due to the greenhouse effect of the Earth's atmosphere? The learning outcomes. The tools presented in this lesson plan will enable your students to 1. Apply Planck's law to plot black body curve of an object at a specific temperature. 2. Apply the Stefan Boltzmann's law to determine the surface temperature of a black body. 3. Calculate the surface temperature of Earth based on the solar energy flux. 4. Explain the effect of the greenhouse effect on Earth's atmosphere on the surface temperature of planet Earth. If you or your students would like to explore this topic further, some additional resources are also provided in this lesson plan that we invite you to take a look at. a lesson plan titled Phase Diagrams and Phase Equilibria. As an undergraduate physics teacher, you can use this set of computer-based tools to teach topics such as phase diagram and phase equilibria. As you know, phase diagrams can be used to understand the stability of different phases of matter, solid, liquid and gas, under changing temperatures and pressures. This lesson plan will help your students to learn about phase equilibria through the example of the phase diagram of water. Students will learn about the phases of water on planet Earth, Mars and Venus, and will discuss the role of the water cycle in making the climate of planet Earth habitable. Thus, the use of this lesson plan will allow you, the physics teacher, to integrate the teaching of a climate science topic with a core topic in your discipline. As a teacher of physics, if you are teaching topics such as phase equilibria, phase diagrams specifically of water, triple and critical points in phase diagram, degrees of freedom, the vapor pressure and so on and so forth, you might want to take a look at this lesson plan for your students. The approximate time required for this lesson plan ranges from 45 to 60 minutes. This lesson plan contains a short video micro lecture about 12 minutes in length that introduces phase diagrams and explains how they can be interpreted using the example of water and its phase diagram. There is another short reading about 10 minutes in length that describes a typical phase diagrams and its components. This includes examples of the phase diagrams of water and CO2 and provides examples and exercises based on these phase diagrams. A short micro lecture and an associated reading that describes the phase diagrams of water on planet Earth, Mars and Venus. In this, your students can discuss the water vapor feedback mechanism in the atmosphere of these planets and the role that this mechanism plays in the greenhouse effect. These resources will help explain why the climate of planet Earth is habitable while that of Mars and Venus is not. Here is a step-by-step guide to using this lesson plan in your classroom. We have suggested these steps as a possible plan of action. You may customize the lesson plan according to your preference and requirements. Step 1. Introduce the topic by playing a short video micro lecture. This video micro lecture titled Phase Diagrams is produced by Khan Academy. You can start by introducing what is a phase diagram and explain to your students what phase diagrams depict by describing their different regions and degrees of freedom. Their students can be asked to interpret phase diagrams under varying conditions of temperature and pressure. Using this particular tool in your classroom, first describe the phase diagrams of water and phase transformations of water at melting and boiling points at various atmospheric pressures. Then you can use the video to describe the phase diagram for carbon dioxide. Note, both water and carbon dioxide are greenhouse gases. That is why we are choosing this particular examples. Further, use this tool to explain what are triple and critical points in a phase diagram and discuss phase transitions at these points. You can introduce the term supercritical fluid and briefly describe its properties at this point. Step 2. You can use a short reading to discuss this topic further. This reading, which is titled Phase Diagrams, is produced by Libretrex and describes a typical phase diagram. In this reading, you can start by describing the different regions of a phase diagram where the various phases of a single substance exist in a stable state and the points at which phase transitions take place. Discuss the triple and critical points in a phase diagram and the stability of phases at these points. Further, examine the phase diagrams of water and CO2 and discuss specific temperature and pressure conditions at which the different phases of these substances are stable or unstable. The particular examples and exercises that we have asked you to use are shown in this lesson plan in the guide itself. Finally, start to make the link between phase diagrams and understanding of climate science through this third resource. This includes a video micro lecture and an associated reading to explain the reasons of Earth's climate being habitable using phase diagrams, specifically of water. First, you can play the video micro lecture titled Water Vapor Feedback, developed by Professor David Archer from the University of Chicago. Here, you can explain the stable phases of water at various temperatures on planet Earth. You can at this point introduce the concept of the water vapor feedback and explain the greenhouse effect of water vapor on Earth's atmosphere by using the phase diagram of water. Further, compare the effect of water vapor feedback on the atmospheres of Earth, Mars, and Venus. Discuss with your students how the water cycle ensures that the Earth has a climate that is more suitable to support life. You can explain the runaway greenhouse effect of water vapor on Venus that makes it uninhabitable at this point too. All this information is provided in the video micro lecture and the associated reading developed by Professor David Archer. The questions and assignments. You can use the tools and the concepts learned in this lesson plan to discuss and determine answers to the following questions. What is a phase diagram? Explain what are degrees of freedom. Define the triple point and critical point in a phase diagram. What are supercritical fluids? How are they useful? Discuss the water vapor feedback mechanism in the Earth's atmosphere through the use of the phase diagram of water. Using phase diagrams, explain why the climate of Earth is habitable while the climate of Mars and Venus is not. Why did Venus experience a runaway greenhouse effect, making its surface temperature extremely high, around 462 degrees C? Discuss why the Earth has not yet experienced this effect. The learning outcomes. The tools in this lesson plan will enable your students to 1. Describe a one-component phase diagram. 2. Explain various regions and points such as the triple point, the critical point in a phase diagram. 3. Define a supercritical fluid. 4. Compare the climates of Earth, Venus, and Mars with the help of phase diagrams of water. 5. Use the phase diagrams to explain the water vapor feedback mechanism in the Earth's atmosphere and its role in making the planet habitable. If you or your students would like to explore the topic further, some additional resources are provided in this lesson plan. We invite you to take a look at them. A lesson plan titled Coriolis Force and Coriolis Effect. As a high school or undergraduate physics or earth sciences teacher, you can use this set of computer-based tools to help you in teaching about the Coriolis force, the Coriolis effect, and how the Coriolis effect can influence Earth's climate through trade winds and upwelling. This lesson plan will allow students to understand the Coriolis force and the effects of Coriolis force on weather and climate. The videos and activities shown in this lesson plan will explain to your students how the Coriolis effect determines the direction of trade winds and upwelling in the oceans. So, as a physics teacher, if you are teaching Coriolis force and the Coriolis effect, we invite you to take a look at this lesson plan and to use it in your classroom for your students to improve their understanding of climate science. The approximate time required for this lesson plan is between 45 and 50 minutes. This lesson plan includes a short video micro lecture about 8 minutes in length that first introduces the Coriolis effect. A short classroom or lab activity, an interactive activity to better engage with your students to explain the Coriolis effect. A short video micro lecture that introduces the topic of what is upwelling in the oceans and how the direction of motion of water is influenced by the Coriolis effect. It also contains another short video micro lecture that introduces the topics of trade winds and how the direction of these winds is influenced by the Coriolis effect. Here is a step-by-step guide towards using this lesson plan in your classroom or lab. We have suggested these steps as a possible plan of action, and you may customize the lesson plan according to your preferences and requirements. First, introduce the topic through a video micro lecture. The topic being Coriolis force and Coriolis effect. This video micro lecture has been produced by Professor Raghu Murtugude from the University of Maryland for a project called the Tropixu project at the Science Media Center in IISER, Pune. This provides students an overview of the Coriolis effect. Next, conduct a hands-on classroom or lab activity titled Coriolis effect activity. This has been created by Laura Rieser-Wetzel from Eckerd College, and it helps students to gain a better understanding of the Coriolis effect. In this activity, students use a simple paper-based model to answer questions and discuss the Coriolis effect. All the instructions of where you can download the files, what are the activities, including instructor notes, student handouts and answer keys are provided in the link in this particular lesson plan. Next, play a short video micro lecture titled Upwelling by Professor Raghu Murtugude of the University of Maryland to provide students an overview of the impact of the Coriolis effect on upwelling in the oceans. At this stage, you can discuss with your students what is the effect of upwelling on the climate of various regions in the world. You can also play another micro lecture titled Trade Winds to provide students an overview of the impact of Coriolis effect on upwelling in the oceans. You can discuss the effects of the direction of trade winds on the climate of various regions in the world. You can use the tools and concepts learned in this lesson plan to discuss and determine answers to the following questions. What is the Coriolis effect? How does the Coriolis effect affect the direction of motion in the northern hemisphere? How does the Coriolis effect affect the direction of motion in the southern hemisphere? How does the Coriolis effect influence the direction of trade winds on Earth? What is upwelling? How does the Coriolis effect affect upwelling in the oceans? The learning outcomes. The tools in this lesson plan will enable your students to 1. Describe the Coriolis effect. 2. Compare the influence of the Coriolis effect on the direction of motion in the northern and southern hemispheres of planet Earth. 3. Discuss the influence of the Coriolis effect on the climate of a region. A lesson plan titled Heat Transport in the Atmosphere, Hadley Circulation and Climate. As an undergraduate geography, earth sciences or physics teacher, you can use this set of computer-based tools to help you in teaching about heat transport in the atmosphere, atmospheric circulation, and the Hadley cell and Hadley circulation. For physics teachers specifically, this lesson plan will help your students to apply the law of conservation of angular momentum and understand the concepts of a thermally direct cell. Thus, the use of this lesson plan will allow you to integrate the teaching of a climate science topic with a core topic in physics. So, as a physics teacher, if you are teaching topics such as Hadley cell, Hadley circulation, heat transport in the atmosphere, thermally direct cells, law of conservation of angular momentum, you might want to take a look at this particular lesson plan. The approximate time required for this entire lesson plan ranges between 80 to 130 minutes. This lesson plan includes a short video micro lecture that introduces heat transport in the atmosphere and what the Hadley cell is. It also explains the reasons for the geographical distribution of deserts on planet Earth. Reading, which takes about 20 odd minutes to discuss the Hadley cell in more detail and explains a simple model of the Hadley circulation using the law of conservation of angular momentum. This might be of special interest to physics teachers. A classroom or a lab activity, an interactive activity to better engage with our students that uses the NASA MERA reanalysis model for a more detailed illustration of Hadley circulation and its importance in Earth's climate system. Here is a step-by-step guide towards the use of this lesson plan in your classroom or lab. We have suggested these steps as a possible plan of action. You may customize the lesson plan according to your preferences and requirements. First, introduce the topic through a micro lecture. Introduce the topic of heat transport in the atmosphere and Hadley cell by playing a micro lecture titled Hadley Circulation Cell by Professor Raghu Murthugude of the University of Maryland. Next, discuss this topic in more detail using the reading provided. This reading, titled Hadley Cells, is from Harvard University. This reading applies the law of conservation of angular momentum to explain a simple model for the Hadley cell, and it also introduces a possible explanation for equable climates in the past. Next, you can choose to conduct a classroom or a lab activity. You can explore this topic in a more engaging manner with your students by conducting a classroom lab activity titled Hadley Circulation using NASA MERA reanalysis model from the program on climate change at the University of Washington. In this activity, your students will analyze and map real data through the NASA MERA reanalysis model to understand the actual impact of the Hadley cell on Earth's climate system. Things such as the geographical distribution of deserts, global precipitation patterns, trade winds. Students will visualize a 30-year average data on winds and their vertical velocity to understand the Hadley circulation and its influence on regional climates. Instructions of how to use this activity in your classroom are provided in the link in this lesson plan. You can use the tools and concepts learned in this lesson plan to discuss and determine answers to the following questions. How does the Hadley cell transport heat in the atmosphere? Describe the geographical distribution of deserts. How does Hadley circulation influence this distribution? What are the possible effects of climate change on Hadley circulation? What might be the potential impacts of Hadley cell expansion on Earth's climate, global precipitation patterns, and its geographical distribution of deserts? The learning outcomes. The tools in this lesson plan will enable your students to 1. Describe the Hadley cell and Hadley circulation, atmospheric circulation and heat transport. Explain the influence of the Hadley circulation on the geographical distribution of deserts and global precipitation patterns. Discuss the potential impact of climate change on Hadley circulation and discuss the possible effects of Hadley cell expansion. If you or your students would like to explore this topic further, these additional resources listed here might be useful. See these lesson plans that integrate topics in physics with climate sciences at TropicZoo at the URL shown in this particular slide. Let us now briefly look at some teaching tools that you as a physics teacher can use in your classroom to integrate the teaching of topics in physics with a climate science topic. This includes things such as a reading on the water vapor feedback and Earth's climate using the phase diagrams of water on Earth, Mars and Venus to discuss things such as the water vapor feedback mechanisms. A reading that explain Earth's equable climate in the past using theories of like Hadley cell, convective cloud feedback, polar stratospheric clouds and tropical cyclones. A short reading that discusses the blackbody emission properties of the Sun and planets, describes the calculation of planetary temperatures using Stefan Boltzmann's law and explains the effect of atmospheres on planetary temperatures. A visualization tool on blackbody spectrum to explain how Planck's law can be used to plot blackbody curves of objects of different temperatures and what the relationship between temperature and peak wavelengths in the electromagnetic spectrum. A reading that discusses the use of the law of conservation of angular momentum to explain the extent of Hadley cells. a model or a simulator to learn about heat transfer in the Earth system and planetary energy balance, a classroom or lab activity to learn about the Coriolis effect, a lab activity to learn about the urban heat island effect and heat waves, a visualization to understand black body radiation, the effects of albedo and solar brightness on the temperature of a planet, and the greenhouse effect of Earth's atmosphere, a reading that introduces a single layer atmosphere model which is based on the emissivity of thermal radiation to explain atmospheric warming, a video to learn about hurricanes as heat engines and the possible effects of increasing sea surface temperature on the intensity and frequency of hurricanes, a visualization to learn about the infrared spectra of different greenhouse gases, a video micro lecture that discusses Earth's energy balance and the greenhouse effect on Earth's atmosphere, and many other tools. Let us take a look at a few of these tools in some detail. The first, a reading on titled Planetary Temperatures. This reading discusses the blackbody emission properties of the Sun and planets, describes the calculation of planetary temperatures using the Stefan-Boltzmann's law, and explains the effect of atmospheres on planetary temperatures. Through the use of this tool, your students will learn to apply the Stefan-Boltzmann's equation to determine the total energy flux emitted by the Sun's surface, and will discuss the differences between observed and predicted planetary temperatures. Using this tool, your students can answer questions such as, what parameters determine the amount of energy received by a planet from the Sun? What is the effect of atmospheres on the temperatures of various planets in our solar system? Some information about the tool is provided in this slide. This tool has been developed by the American Chemical Society at the link that is shown here. A visualization tool titled Blackbody Spectrum, to continue from our last one. This visualization can explain how Planck's law can be used to plot blackbody curves of objects with different temperatures, the relationship between temperature and peak wavelengths in the electromagnetic spectrum, and the greenhouse effect of Earth's atmosphere. Using this tool, you can ask your students questions such as, how can Planck's law be used to plot blackbody curves of objects at different temperatures? What is the relationship between temperature and peak wavelengths in the electromagnetic spectrum? Why does the surface temperature of Earth increase due to the greenhouse effect of Earth's atmosphere? This tool, developed by PHET Interactive Simulations at the University of Colorado at Boulder, can be found at the link shown here. A reading titled Atmospheric Dynamics and Hadley Cells. This reading discusses the use of the law of conservation of angular momentum to explain the extent of Hadley cells. Students will learn to derive atmospheric dynamics equations for a model of Hadley circulation which is based on Farrell's theory. Using this tool, help your students find answers to questions such as, according to Farrell's theory, what factors determine the extent of Hadley cells? This tool has been produced by Mark Priana at Harvard University. A short reading titled Simple Atmospheric Model. This reading introduces a single layer atmosphere model which is based on the emissivity of thermal radiation to explain atmospheric warming. Through the use of this tool, your students will learn about the absorptivity and emissivity of gray bodies, the equation for planetary energy balance, the emission profiles of different sources, while understanding a simple model to determine planetary surface temperatures. You can use this tool in your classroom to help your students find answers to questions such as, define emissivity and absorptivity, describe the single layer atmosphere model for atmospheric warming. This tool has been developed by the American Chemical Society and is available at the link shown here. So, physics teachers, we request you to take a look at some of these lesson plans and some of these teaching tools in order to teach topics in physics while simultaneously improving the understanding of your students of a very, very important topic of our time, that is climate change.